Is it possible to store excess energy from solar energy systems? Exciting developments are happening in the world of renewable energy. A hot topic right now is whether we can store excess energy generated by solar energy systems. As more people turn to solar power, the question of energy storage becomes increasingly relevant. With solar energy being intermittent, finding effective storage solutions is essential for a reliable power supply. Yes, it is possible to store excess energy generated by solar energy systems, and this is a key area of focus in electrical engineering. Solar energy is converted into electricity using photovoltaic panels. However, since solar generation depends on sunlight availability, excess energy produced during peak sunlight hours can be stored for later use. This stored energy can be utilized during nighttime or cloudy periods when solar generation is low. Several methods exist for storing solar energy. The most common approach is using battery energy storage systems. These systems store electrical energy chemically and releases it when needed. Modern lithium-ion batteries are widely used for both residential and utility-scale solar-plus storage projects. For example, projects in Australia are developing large-scale solar-plus storage plants with battery systems capable of storing energy for 4 to 8 hours. This allows for a steady power supply beyond daylight hours. Another method is thermal energy storage. Some solar power plants, especially concentrated solar power facilities, use thermal storage methods. Molten salt tanks can store heat collected during the day and releases it to generate electricity after sunset. The Andasol concentrated solar power plant uses this technique, and the Solana generating station in the United States provides 6 hours of energy storage using molten salt tanks. This allows it to generate electricity even when the sun is down. Pump storage hydroelectricity is another effective method. This technique stores energy by pumping water to a higher elevation during periods of excess solar generation. When electricity is needed, the stored water is released to generate hydroelectric power. This approach combines solar arrays with pumped hydro facilities, as seen in some installations in Germany. Research is also ongoing into converting excess solar energy into chemical fuels like hydrogen or ethanol. This involves using catalysts to drive reactions that store energy in chemical bonds. These fuels can later be used for transportation or industry. Advances in artificial intelligence are helping discover more cost-effective catalysts to make this process scalable. The challenge with solar energy storage lies in cost, scalability, and efficiency. Batteries and other storage technologies add expense and complexity. However, they are vital for integrating solar power into the grid reliably. As solar power is variable due to day and night cycles and weather, storage systems help balance supply and demand. This makes solar a more dependable energy source. Storing excess solar energy is not only possible but is increasingly implemented through batteries, thermal storage, pumped hydro, and emerging chemical fuel technologies. These solutions are essential for maximizing the use of solar power and supporting the transition to renewable energy systems.